Hey there everyone, my name is Arish Asif Khan and today we are going to be learning about the sum and product of the roots of a quadratic equation. We will be covering the sum and product formulas along with some easy examples. Firstly, let's start with the theory, deriving the sum and product formulas. Suppose we have a quadratic equation ax squared plus bx plus c which is equal to 0 and it has two roots, alpha and beta, which is found using the quadratic formula. So the root for alpha is going to be minus b plus under root b squared minus 4ac divided by 2a. And for beta, it's going to be minus b minus under root b square minus 4ac divided by 2a. Now, what is the sum of the roots going to be? If we take alpha and beta and add them together, we'll get minus 2b over 2a. If you look at under root b square minus 4ac, it gets cancelled because of the opposite sign, while minus b and minus b results to negative 2b. So minus 2b over 2a, that's equal to negative b over a, since the 2 got cancelled with the denominator. So that is the sum of roots. Alpha plus beta is equal to minus b over a. And what is b and a here? If we have a quadratic equation like we had above, ax squared plus bx plus c. So b and a are the coefficients of x squared and x. Moving on to the product of the roots, alpha into beta. So minus b plus under root b square minus 4ac divided by 2a is multiplied with minus b minus under root b square minus 4ac over 2a. How are we going to expand this further? We're going to take the third identity, which is a square minus b square being equal to a plus b into a minus b. So minus b whole square, this is a, and under root b square minus 4ac, that is b. So minus b whole square minus under root b square minus 4ac whole square. That is equal to b square minus b square plus 4ac. And the denominator 2a into 2a is equal to 4a square. B square minus b square is just equal to 0. So 4ac divided by 4a square. The 4 is going to get cancelled and so is the a in the numerator. So the final a into b, or the product of the root, comes down to c over a. And like we discussed, for the sum of the roots, c and a are the coefficients. A is the coefficient of x squared while c is a constant. So these are the formulas that we derived. The sum of roots is equal to negative b over a and the product of roots is equal to c over a. For the first example, we need to find the sum and the product of the roots. Looking at part 1, here we have x squared minus x plus 2 which is equal to 0. What are the values of a, b and c? A will be equal to 1, b will be equal to negative 1 and c will be equal to 2. So if we take the sum of roots formula, which is minus b over a, and place our values, we get alpha plus beta being equal to positive 1 over 1, which is simply 1. And for the product of roots c over a, it's going to be 2 over 1, which is 2. So we found the sum and product of roots for our first part. Moving on to the second part, here we have a quadratic equation, which is x squared minus 7x plus 5 being equal to 0. So the value of a is going to be 1, the value of b is going to be negative 7, and the value of c is equal to 5. So what is the sum of roots? As we discussed earlier, alpha plus beta is equal to negative b over a. So let's place our values. 7 over 1 is equal to 7, so that is the sum of roots. And for the product of roots, 5 over 1 is equal to 5. So we also found the sum and the product of roots for our second part. Moving on to example number 2, here we need to evaluate the expressions in our roots. We are given a quadratic expression which is x squared minus 8x plus 20 is equal to 0. The sum of roots is 8 and the product of roots is 20. Now by these given values, we need to solve the below expressions. Looking at the first part, here we have alpha squared plus beta squared. So firstly, we will add 2 alpha beta and subtract 2 alpha beta. So that comes up to alpha plus beta whole square minus 2 alpha beta. Now we know that alpha plus beta is 8. so the square of 8 is 64. Alpha beta is 20, so 20 into 2 will become 40. 64 minus 40 is equal to 24, so that's the value of alpha square plus beta square. Moving on to the second part, which is alpha minus beta whole square. Now, alpha minus beta whole square can be written as alpha plus beta whole square minus 4 alpha beta. We know the value of alpha plus beta, which is 8. So the square of 8 is 64. And alpha beta is 20, so 4 into 20 is 80. 64 minus 80 comes up to negative 16. So that's the answer of the second part. And for our final part of example number 2, we have 1 over alpha plus 1 added with 1 over beta plus 1. So for alpha plus 1, we are going to multiply beta plus 1 over beta plus 1. And for beta plus 1, we are going to multiply alpha plus 1 over alpha plus 1, so that the denominators are the same. As the denominators are the same, we can start expanding this. So alpha plus beta plus 2 over alpha beta plus beta plus 1. We'll just simply input our values. Alpha plus beta is 8, so 8 plus 2 is going to be 10. Our numerator right now is 10. Alpha beta is 20, alpha plus beta is 8, and 1 stays 1. So 1 is added with 8 and 20, which comes up to 29, which is 10 over 29. That's the value of 1 over alpha plus 1 added with 1 over beta plus 1. I hope you guys liked my lecture. If you did, make sure to subscribe to my channel and share this video with your friends and family so they can also benefit from it. Thank you.